Hey, welcome back. As you can see, I bought a new chuck for my lathe. This is a 125mm 6-jaw chuck made by Zentra, which I think is a Bison clone or a Bison licensed product, but I tend more in the direction of clone. These are made in China, of course. Cost way less than, for example, a room 6-jaw chuck, especially with a steel body and the fine adjustment. The set true, high true, buck chuck, whatever you want to call them. Fine adjustment that can move the chuck around on the backplate. Currently I have a 3-jaw chuck, as most people on my lathe, as my main chuck. But I wanted a 6-jaw for a long time because I do a lot of plastic and it's easy to wiggle a plastic part out of a 3-jaw chuck and throw it across the room because there is so much space between the 3 jaws, and then you can lever the part and the plastic is soft and it works itself out of the jaws. And with the 6-jaw chuck, this shouldn't happen because the space between the jaws is very small. Half as big, basically. And yeah, I finally wanted a chuck with set through with the adjuster. That means you mount this on a back plate, then you have 4 set screws, and the centering spigot here on the adapter plate is undersized. And you have 4 set screws, and when you loosen the mounting screws that hold the chuck on the back plate, you can move the chuck around very precisely with these fine threaded set screws. These are M12 by 1 fine threaded set screws. Very large diameter fine threaded set screws. Very, very long thread engagement, as you can see. These are hard to wear out. And why am I showing this to you? Not because I want to brag, but because I want to take it apart. As you know, don't turn it on, take it apart. My usual procedure with Chinese chucks and collet chucks and vices and whatnot is you get them, you take them apart, you clean them, and you do some deburring. That didn't happen at the manufacturer most of the time. And yes, a 6-jaw chuck, even from Zentra, is not cheap. It's 450 euro. I bought it from Sand Tool here in Germany, but I'm pretty sure you can get them all over the world. And yeah, got it delivered within 2 days. All good. Came with the inside step jaws for large diameter, came with the outside stepped jaws for small diameter work, came with a chuck wrench. I don't know how this happens all the time. I always lose the spring on the key. Came with 12.9 grade high strength screws to mount it to the back plate, like this. And yeah, overall feel is very good on this chuck. The action is very nice and tight. This is not a free spinning chuck. The jaws sit very tight in their guiding slots. And it feels like the spiral gear in here is also a very tight fit in the body. So let's get the jaws out. They put a liberal amount of grease on them, which is nice. It's better than lapping compound, which I had also, or grease mixed with cast iron granny grit. So that's a nice touch. I'm not sure how these go apart, but I guess we have to unscrew the back side. Okay, I tightened these screws down reasonably. like crazy. Also 12.9 strength screws. And there it goes. Oh. Ta-da! Okay, there is a dowel pin for alignment. This is good, so it cannot go together in the wrong way. There's some grease in here. All in here is quite massive. This is all steel. Yes, this is a steel body chuck, not a cast one. Okay, these parts will all go in the ultrasonic cleaner. There is some gunk on them. Okay, this is an interesting construction. The pinions come out there together with the bushing they run in. The pinions are secured in these bushings with this half-moon ring. This goes out. This seems to be ground to thickness. It's a reasonably tight fit in there, and this secures the pinion in this bushing, the steel bushing. You can drop this out, and this is all ground all around, including the slit, and we can hit it with a needle file. Yeah, this is hardened. I'm not sure if these parts are match fitted, so I better keep them separated. Yeah, there's a large amount of grease in there. Not very dirty. Some burrs, but those will clean up fine. There is the dowel pin that aligns top and bottom. This is nice, so it cannot go together the wrong way. Let's see if we can get the spiral ring out there. With a piece of plastic and just... Oh yeah, this comes out. There we go. Yep, what you expected. The gear side is machined okay. The spiral here is really machined very nicely. Almost looks like a ground finish on the spiral itself. Looks decent to me. The pinions are so and so. At least the sliding surfaces are ground, but the pinion itself is relatively rough, machined or whatever. So I will clean all these parts and then I will come back. So I deburred everything, put it back together with some molybdenum disulfate. And there's another thing with the set-through chucks that Robin mentioned. The register diameter on the backplate is, of course, smaller than the ID of the chuck, and chips can migrate over time between this larger diameter and this smaller diameter down here and crunch things up, and you want to avoid that. He showed to use a piece of a pool noodle, cut down in a thin slice and put in here as a seal. And I just cut a piece of packing foam, PE foam, polyurethane foam, to a ring. And this will do the same. It will crush down to the thickness of the gap and seal out any chips. The back plate goes on like this, and as you can see, there's a gap that it crushes down nicely. And I just used flat packing foam, 8mm thick, cut out with scissors, and the ID with a scalpel. So let's flip this around. Drop the screws in. There we go. That's the chuck with the back plate. Here are the adjuster screws that can slide the back plate around. And here you can see the flats I machined on here. This allows me to clamp the chuck in the vise of the mill if I want. I would have to pull out these 3 studs, of course, because these stick out too far. This is the spindle nose of my lathe. As you can see, it has a plain face and a cylindrical shoulder here. It's very similar to a short taper spindle nose with bayonet disc. This is the locking implement. The chuck has 3 studs on the end. They go through the bayonet disc. Then you twist this a few degrees. And as you can see, it closes up. Then you tighten the 3 nuts all around and you're good. Normally, this design of a spindle has a short taper here, 7 degrees something something. But on the smaller hobby lathes, you will find a lot of times that there is just a cylindrical diameter. There we go. I only have short road broaches, so I have to flip the part around. And there we go. Oh, it's not even hot. The rotor broach is always a nice fast way to punch a hole through some material. And always leaves a nice slug of material. I'm boring the recess that goes onto the spindle nose, and it's always a good idea not to blow the cast iron dust, fine graphite iron mixture all over the shop with compressed air. That's a case where the vacuum cleaner is a good idea. On shallow, large diameters like this, internal diameters, I like the 2-point internal mics very much. They work very well. On small diameters, not so much, but on large ones, they work very good. And I'm using, as usual, the technique of balanced cut. I'm 0.3 millimeters away from my final dimension. I took a 0.15 millimeter cut. Now I'm checking my dimensions if it's the same as I read on my DRO, which it is. Otherwise I would have to correct slightly. And now I can take my remaining 0.15 millimeters and I will hit my diameter here perfect. Without any guesswork, without any hooba-dooba or whatever. Just by taking even cuts on the last 2 passes and measuring in between. Okay, there we go. Cleaned up the OD to the same diameter. In fact, 0.5 millimeter undersized to the OD of the chuck, because when the chuck moves around with the adjust through function, I do not want the flange overhang the chuck. I want always the chuck to be overhanging. While I have it still in the chuck, I took the whole chuck with the flange mounted in it off the spindle to do a test fit. And the reason for that is that way I can mount it back on the spindle and not lose my runout and my trueness of rotation and whatever. But I still can test fit my spindle, my adapter plate here to the spindle nose. But as I'm very confident in my measuring equipment, there is not a problem as it seems. Yes, that's good. Okay, let's get the chuck back on the spindle. Let's clean out all the cast iron gunk back here. And this chuck is not Chuck Norris. Now I'm going to put some shim stock under it because I do not want to mar up my new freshly machined surfaces here. This unmachined part, this clamping ledge that I had in the chuck, will get removed once I turn down the diameter for the 6-jaw chuck. Say that 100 times fast. 6-jaw chuck. I just surface ground the back side of the flange. The cross traverse travel of my grinder is too small to hit the whole surface, so I did the spot grinding technique. Take one pass, rotate it a little bit, take a pass, rotate it a bit, and so on until you get all the way around. And this leaves this neat pattern, which looks kind of cool. And a pretty darn flat part, even if it overhangs the travel of your grinder a bit. It's definitely time to build a spin grinding fixture, rotary grinding fixture. Like a spin table for surface grinding. Now we have just... Ugh. And that's the weird pattern you get by this technique. I really like this this look of a surface. Checking for parallelism, which is not super important, but I want to see if the surface is flat too. And this is a 1 micron indicator. And that's okay. I'm measuring a lot of surface roughness here. But I think that's not too shabby. Keep in mind this goes on a lathe, not on a cylindrical grinder. Clamp the part to the table and I'm centering it with my dial test indicator. Already got it centered up pretty good. And I will change to a drill chuck and drill these 3 mounting holes with a M10 thread. Setting up the DRO for bolt circle. Hit bolt circle, pitch circle diameter in XY direction. Position is 0, 0. That's the center of our bolt hole pattern. Diameter is 74 millimeters. Starting angle is 0. End angle is 360. Number of holes is 3, but to make it easier with the DRO, we enter 4. Otherwise, the end angle has to be 360 minus 120 degrees. And if I just enter 1 hole more, I can go 0 to 360. And that's our first hole position. You have to be in absolute, not in incremental. Otherwise, you get a pretty messed up position. Power tapping the M10 threads. I'm holding the tab in a room keyless chuck, and generally those do not make a problem in my experience with power tapping. The room ones are not, they are very decent chucks, not as good as a Albrecht, but they're very decent and reasonable priced. And they work for power tapping very well, even up to M10 or maybe M12 thread, and at least cast iron and steel, it's not a big problem. I'm borrowing these studs from my 3-jaw chuck. You cannot buy these are not off the shelf studs. So I turned them out of 42 chromoly myself. So I got the flange mounted to the spindle, turned it down to the right diameter for the adjust through set screws, and I relieved the center about to here, and the chuck is only sitting on this rim out here, about a band of about 20 millimeters width. Okay, I cut 2 flats on both sides parallel to each other onto the flange or adapter, so I can hold the chuck with the adapter plate in the vise if I need to do drilling work on a part that I turn in the lathe in one setup and not lose my precision offset in the chuck. Maybe even have to go back to the lathe. Gives you more options. That's again something that Robin Rancetti showed on, I think he showed it on Instagram, and so it's a good idea to do it. Okay, I put the flange on my surface grinder, and as you can see, this is about the maximum height I can grind on this machine. I'm 115 millimeter above the magnet. And it's getting pretty tight here. I have about half a millimeter of travel left. If the wheel I'm using right now was not worn down so far, like with a new 125 millimeter wheel, I would not be able to grind this. So I always like to keep a small wheel around with this grinder. Got the chuck mounted on the lathe, and I have a piece of 20 millimeter hardened and ground round stock in the spindle, which is nice, straight and round, and I'm indicating it. And this doesn't look too good, but that's because I have not set the chuck to run through in any way. The screws in front here that hold the chuck to the backplate are semi-tightened, just so the chuck does not fall off and slide around that low. So now we're indicating, and we'll look for the lowest spot like this. This is minus 32, and this is plus 4. So if we tighten this screw here, we will lift the chuck up. Just like this. And we're already pretty darn close. A little bit here. And that's the first time I use an adjustable 3-jaw chuck. Or 6-jaw. Sorry. This is well within 1/100th of a millimeter. Now I can tighten down these screws in front here. Let's see. you can see, it's 0 run out now. Let's open it. Spin the bar around a little bit. Get it back. This locks so nice and solid. But I'm not sure which of the pinions I used. Oh yeah, yeah. That's the trick with a scroll jaw chuck. You always have to need to use the same pinion. See, when I use this one, loosen the part, spin it a little bit, and retighten it. It runs dead true again. If I use, for example, this pinion, runout will be all over the board. 0.04 millimeters. It's not terribly bad, but if you want to do precision work and repeatable precision work, you always have to use the same pinion, because the scroll thingamabob in here will squirm around in different directions, and always using the same pinion will always load it the same way and give you the same runout. So if you go back to this pinion, bam, almost 0 runout. And I know the argument. A lot of people tell you that a scroll chuck on a lathe does not need to run true because it's only a first op tool, and the order of operations will help you to make parts. So it's just not necessary to have a good running scroll chuck on a lathe. I'm of complete opposite opinion. Just because people say that you don't need one, don't let this stop you from getting a good chuck and make it run very well. It makes stuff so much easier if your chuck is not all over the place. If you can endo a part, indicate it in, and have it run basically 0. And yes, there is the famous 4-jaw chuck, but that's nothing for the work I do. I rarely have work that needs a 4-jaw independent. In fact, I own a 4-jaw independent, small one, but I used it over the last year, maybe never. Everything I do fits in a 3, 6, or whatever chuck, or in a collet, or on a faceplate, or in a fixture, or whatever. I basically have no need for a 4-jaw. And this has this. I really like this chuck already. I hope you enjoyed this look at the Zentra 6-jaw chuck and the making of the backplate. And because I forgot it in the video itself, the material for the backplate is continuous cast gray cast iron, GG25. So thank you all for watching, and see you next time.